Okay, guys, I cut that one off, that last video off, and made two of them. Or turned it into two, I should say. So this is still, let's write it out here. This is still Unit 1A. This is Day 3. And this is all for grade 11 University Math. I'm Mr. Lupos. And we did complex trinomials, or we didn't do complex trinomials, that's what we'll do today. We did simple trinomials, we did difference of squares, and we did common factoring yesterday. So back to different types of factoring right now. Complex trinomials, this is still ax squared. Trinomials are usually ax squared plus bx plus c. And yesterday they were simple in that all of our a's were 1, so we had things like x squared plus this and x squared minus that and that sort of thing. Now we start off with something that isn't 1, so here we have a 10, for example. Let me get rid of that. So same sort of format. There's two different ways we're going to do this today, but same sort of format as yesterday, kind of. What you want to do with the complex trinomials is you want to find two numbers that multiply to what a and c multiply to. So this number here and this number here. So I have 10 times minus 3, which is negative 30. So I want two numbers that multiply to negative 30 and that they add to just what b is. So they add to what b is, and in this case it's here, and if you look at it, it's negative x, so that would be kind of a tricky one, negative 1, but you guys are smart. So I want two numbers that multiply to negative 30 and add to negative 1. I play around with my multiples of negative 30. They multiply to negative 30. One's got to be a positive, one has to be a negative, and they add to negative 1, so the bigger of the two has to be negative, and my answer is then negative 6 and 5. Okay, so negative 6 times 5 is negative 30. Negative 6 plus 5 is negative 1. So decomposition, this is two ways. This is number one. This is decomposition. This is an algorithm. This is hardcore math type style stuff. I don't know how you learned it last year. People teach it different ways. I'll do it both ways. I used to prefer this way, but I don't think there's any doubting that the other way is quicker and easier. We'll get to that in a second. So what you do is you write the 10x squared the same, and then you write the minus 3 the same, but we're going to break up this negative x into these two pieces here, into negative 6x plus 5x. And if you ask, why do you do that? Well, you do it to get to where you're going to be at the end. At the end, we're going to have two factors, bracket, 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 bracket. And if we do this step here, break it into these two pieces here, negative 6 and 5, we will get here. Okay. Then you look at these four different terms separately, and you have these first two terms, and then you have the last two terms. And you common factor both sets. So here you have this pair here, 10x squared minus 6x. That's even, that's even. So I can get a 2 out. I have an x, and I have an x squared, I have an x. So I'll take 2x out. And that leaves me with 5x, and that leaves me with minus 3. Here, 5x minus, this is a good example because I have 5x minus 3, and I look at it, I go, I can't factor anything out. But you have to factor something out. That's a bit of a rule here. And if it was a negative, you'd factor the negative. But in this case, it's just, you look at it and you say, well, 5 and 3, what's the biggest common factor between 5 and negative 3? Well, it's 1. Okay, so you have to put something there, and in this case it's 1, and you're left with 5x minus 3. At this point, that's a 1, and that's a bracket. At this point, you know you're on the right track if what's here and what's here are the same, because those guys here can now be common factored from this term and this term. So now I have something times 5x minus 3, and I have something times 5x minus 3. So I'll common factor the 5x minus 3 out. And what are my two somethings? Well, it was a 2x and a 1. So I just write out this and this. So this guy goes here, this guy goes here, and the signs go with them. This is plus 2x. We don't usually put the plus here, but you do need the plus 1 here. Okay, so that's it. Done. That's simple. That's complex trinomials, and this is through decomposition. Okay, so that'll work every time, and it's pretty good stuff. And you know what you're doing as you do it. The other one method is this guy here. Might give it away. The other one is we're going to go. Can I do this? This is high tech here. We're going to go down under. Anyway, you get it? And we're going to flip this. I don't know. Anyway, so this guy's Australian. So this is called the Australian method. I think it's illegal to spray paint on a kangaroo. I'm not sure though. So it's the same question. Let's go back for a second here. Let's go back. So we're going to do the same question. And at the end, I had 5x minus 3 and 2x plus 1. So let's make sure we're going to end up with 5x minus 3 and 2x minus 1. So let me make sure that was right. 5x minus 3, 2x plus 1. Plus 1. Good. Okay. So that's plus 1. So this is the way we do this one. You start off the same sort of way. you need two numbers. They start off the same. You need numbers that multiply to 30 again. This times this, and oh, sorry, I copied this down. Give me a second. So this was just if we go back to the last question, 10x squared minus x minus 3. Let's go back and make sure it's right. 10x squared minus x minus 3. Good. Okay, so I want two numbers that multiply to negative 30, and they add to negative 1. So they multiply to negative 30, so 10 times negative 3, the same way as before, and they add to whatever this is, which is minus 1. And again, those two numbers were, what, negative 6 and plus 5. But this is the same sort of thing, and there's division, and there's a long version to do it, but I'll just do the quick way now, okay? What you do is you rewrite this 10x, this thing right here. You write out 10x squared, but you just write it as 10x. So you have 10x, and you put it over one of these numbers, minus 6. Then you write out 10x again, and you put it over 5, okay? So you take your two numbers here that multiply to negative 30 and add to negative 1, and you put them down here, and that's 10x, okay? Then you common factor. And you look at it and you ask yourself, can I common factor anything out here? Can I reduce? I shouldn't say common factor. Pretend this is a fraction. 10x over negative 6. Can that be reduced to lowest terms? Well, they're both even, so it can't. Okay, I'll divide by 2. I'll divide by 2, and I'll end up with 5 over negative 3. Here, I have a 10 and a 5. I can actually divide by 5, and I'll be left with 2, and divide this by 5, and 1. So here I have 5x minus 3. 5x over minus 3, which is 5x minus 3. And here I have, if I didn't mess this up here, if I had written that over there, you would see that I have 2x plus 1, which is in fact this here. Okay, a little hocus pocusy, a little phony for my liking, kind of. The math behind it's good, but we're skipping a bunch of steps. But then again, we do skip steps. Once you get comfortable with stuff, we do skip steps, right? We don't always write out every step when we multiply or add or collect like terms. We jump around a bit. So I thought about that for a while, and I said, you know what, I'm going to allow this to be taught and to be used in my class from now on, because it's very efficient, right? You get the right answer, and the only thing you have to be careful with is it will blow up in your face pretty horribly if you don't common factor. So if, let's say this was, let's just change this guy, we're going to double everything to 20x squared minus 2x minus 6. You want to common factor this out first, so what you do is take the 2 out and then go like this. Okay, so you're going to common factor the 2 out. Then you're going to go and do all these steps here and get your two factors here. But at the end, you're going to remember that the 2 goes in front of the whole thing. So you have 2 times one factor times the other factor. Okay, and that's really it. So decomposition, simple trinomials, complex trinomials by decomposition, or complex trinomials using the Australian method, up to you, your call. Okay, enjoy, and a little bit of homework, a quiz tomorrow also.